Alright, on the previous video we talked all about polynomials, what they are, why they're important, and just some basic properties of them. In this video we're going to talk about arithmetic, basic arithmetic of polynomials, and basic arithmetic generally when that means is addition, subtraction, multiplication, and division. We're going to talk about division in a different video, so we're just going to focus on addition, subtraction, and multiplication in this one. Also, if you've ever done this before, if you ever just combined like terms or done FOIL, distribution of two polynomials, multiplication, you can just skip this video. Like, this might not be useful to you. But when we talk about addition and subtraction, all that means is we're going to combine like terms. So like terms of a polynomial are those that have the same combination of variables raised to the same exponent. So in this polynomial here, the 5x and the 3x, those are like terms. So if we look at the variable, which is x, and the degree of the variable, or the exponent there, they're both x to the first power, right? These are both x to the first power. We just don't usually write the 1 there. So we can combine these, and this polynomial can be rewritten as x squared plus 5x plus 3x, which is 8x plus 1. So let's work with these two different polynomials here. There are two different polynomial functions. I'm just changing this a little bit. Uh, f of x is equal to 3x plus 2, and g of x is equal to 2x minus 1. So I want to know, what is f of x plus g of x? Well, I would just write 3x plus 2 because that's f of x, and then I would add to that the 2x minus 1. Okay, and that 2x minus 1, you can kind of think of it as being in parentheses because I'm adding that whole thing. And now we just need to combine like terms. So it looks like the 3x and the 2x can combine to be 5x, and the 2 and the 1 can 2 and the negative 1, right? 2 plus the negative 1 is just 1, so this would just be 5x plus 1. Now, let's look at what would be f of x minus g of x. So here we would have 3x plus 2, and then minus this 2x minus 1. Now right here, this is maybe one of the things that students miss the most, and it's when we're subtracting this entire thing in the parentheses here. So that means that this negative sign needs to distribute through to both of those terms. So we can start right away by rewriting this as just 3x plus 2, and then minus the 2x, and that's minus a negative 1, so it's plus 1. So now if we combine like terms here, we can look at the 3x and the 2x, and that's still 3x and the negative 2x, that's just x, right? And if we have the positive 2 plus 1, right, plus 1, that's just 3, so that's just x plus 3. Now this process applies to polynomials of all different degrees. So if we have these two polynomials here, where we have x squared, f of x is equal to x squared minus 2x plus 1, and g of x is equal to 3x squared minus 4x minus 2, and we wanted to add those two, we do the same thing. So again, we would write x squared minus 2x plus 2 plus, and then this whole thing is 3x squared minus 4x minus 2. And then we can look at the like terms. So we have x squared and 3x squared. If we add those together, we'll have 4x squared. And then we can look at the negative 2x, and then so it would be a negative 4x. So that's going to be minus 6x, total of negative 6x. And then the 2 and the negative 2, that's just 0. So we end up with this 4x squared minus 6x. That is f of x plus g of x. Now f of x minus g of x, similarly, we do it with x squared minus 2x plus 2, and then again, we subtract everything inside these parentheses, 3x squared minus 4x minus 2, and it can be really helpful to first distribute this negative through, so we would rewrite this as x squared minus 2x plus 2, and then minus 3x squared minus a negative 4x, so plus 4x, and then minus a negative 2, so plus 2. So now we can combine like terms again. We've got the x squared and the negative 3x squared. That's going to be negative 2x squared. We've got the negative 2x and the positive 4x. That's going to be positive 2x. And then we've got the 2 and the 2, and they're both positive, so that's just going to be 4. So negative 2x squared plus 2x plus 4 would be the answer to f of x minus g of x. Alright, now multiplication of polynomials can be a little bit more involved, but really all it is we're going to multiply two polynomials together, and we do that using distribution. Distribution is nothing new. And here we have, basically we've got one polynomial which is x and another polynomial which is x plus 2. And if we want to multiply them together, well, it's natural that we would just do this dive bomb thing here, which is called distribution. We're going to multiply the x by the x, and we're going to multiply the x by the 2. So this is going to be x times x, which is x squared, and then it's going to be x times 2, which is 2x. That's it. A little bit more involved is if we have this polynomial here and this polynomial here. These would be two linear polynomials being multiplied together. A common way that you might have heard of this, a common way to refer to this sort of multiplication is called FOIL, where you take the first terms, right, that's f, first terms, you take the outer terms, that's O, okay, you take the inner terms, that's I, and you take the last terms, that's L. Really all we're doing here is making sure that each term has been multiplied by, each term in one of the polynomials has been multiplied by each term in the other polynomial. And so the way this would work then is we would take x times x, which is x squared. We take x times negative 3, which is negative 3x. And then we would go to, that's everything with the x. Now we'd go to the 2, and we say 2 times x. That's plus 2x. And then the 2 times the negative 3, that's negative 6. And then all we have to do is combine like terms here, because we have the 3x, the negative 3x, and the positive 2x. So this would just end up being x, this should just end up being x squared minus x minus 6. So that's how you do multiplication. This procedure for multiplying scales up, and we can multiply two higher degree polynomials together. If we had a third degree polynomial, or if we had a polynomial with 3 terms times another polynomial with 3 terms, all we have to do is just make sure that we are distributing, we're multiplying each term in the first polynomial by each term in the next polynomial. So for this one here, we are given f of x is equal to x plus 2, and g of x is equal to 3x squared minus 5x plus 6. So if I'm going to multiply them together, that means just x plus 2 times 3x squared minus 5x plus 6. So I'm going to multiply the x times 3x squared, that would be 3x cubed. I'm going to multiply the x times the negative 5x, that's negative 5x squared. I'm going to multiply the x by the 6, that's plus 6x. Then I'm done with the x, I'm going to move on to the 2 in the first polynomial. I'm going to multiply the 2 times the 3x squared, so that's plus 6x squared. I'm going to multiply the 2 times the negative 5x, that's negative 10x, and the 2 times the 6, that's 12, positive 12. So now I have to combine like terms. You see that I have two x squared terms and two just x to the first term. So combining like terms there just is going to give me, first of all, I have that 3x cubed, that's by itself, and then negative 5x squared and positive 6x squared leaves me just a single x squared, and then 6x and negative 10x leaves me with negative 4x, and then there's just that positive 12 there at the end. So to multiply those two polynomials, and this again scales up if we have higher degree polynomials. You're just going to do that. You go from one term and then you multiply it every term in the next polynomial, and then you keep going. Now, so 3x cubed plus x squared minus 4x plus 12, you'll notice that that is also a polynomial. So I could very well just say that this is like h of x. And so important to note here is that if we add two polynomials together, if we subtract two polynomials, if we multiply two polynomials, we are just always going to end up with another polynomial. This doesn't seem very important, but it is. This is kind of crucial to the understanding of sort of the composition of a polynomial, or like what are the things involved in a polynomial. Okay, so in summary, to add or subtract polynomials, all you do is combine like terms. To multiply polynomials, you just distribute. It's just a kind of a more complicated distribution. If you add, subtract, or multiply two polynomials, you just get another polynomial. Now, I mentioned before why this is important, but it's also important because this kind of question actually shows up a lot on like standardized tests. It'll say, given f of x is a polynomial and g of x is a polynomial, what could be said about the product of f of x and g of x? And it'll have all these statements on there, and one of them will be like, it is a polynomial, and that's most likely the right answer unless there's some other more complicated kind of like answer they're trying to give you if they give you what f of x and g of x actually are. Also, the last thing, and I didn't really mention this, but it's a convention, and when we say convention in math, we just mean it's kind of the standard way of doing things. Just because if we do things one certain way, then it's just easier for everybody else to understand. And is to write a polynomial in order of descending degree. So what that means is if you look at the exponents here, 4, 3, 2, and 1, the x to the first power, we don't write the 1, we're going down from a higher number to a lower number. So in this case, we could also say that that 1 at the end is just x to the 0. If we have x to the fourth plus x cubed plus x squared plus x plus 1, we could say that that 1 is 1 times x to the 0. X to the 0 is just 1, or anything to the 0th power is just 1. So that is the last thing there to know, is that the convention for writing polynomials is we write them in descending order. So that's addition, subtraction, and multiplication of polynomials, and the next video we will start talking about division of polynomials.